This will be the final video in this particular series dealing with solutions of typical equations from college algebra. In the last video, we dealt with systems of linear equations. Those were first degree equations. In this video, we'll look at systems of nonlinear equations. That means that at least one of the equations will be nonlinear. So generally, it's going to be a second degree equation. So what happens is one equation could represent a line. The other one could be a parabola. Say we have a parabola that looks like this, and then we have a line. Say it crosses the parabola at 2 points. We're going to have two solution pairs. Maybe the line crosses at 1 point, say right here. One solution pair. If it's below over here and doesn't cross the parabola, then you have no solution. Or let's say we have a circle and say maybe an ellipse. You can see they cross at 4 points, so you'd have 4 solution pairs. The thing about it is you don't have to know what the graphs represent because the procedure is algebraic. So it's just a matter of solving the system either using a substitution or elimination method or a combination. So in this particular case, I have 3x minus y is equal to negative 2. That represents a line. The second one is 2x squared minus y is equal to 0. That's the one that's nonlinear, second degree, because of the exponent 2 here on the x. So I'm going to try to solve these by simply eliminating one of the variables and getting it down to one equation with one variable. So one way to do it is to say multiply the first equation by negative 1 and then adding. So negative 1 times 3x is a minus 3x added to 2x squared. Okay, so this will give me minus 3x. And the plus y and the minus y cancel when I multiply by the negative 1. And then the negative 1 times the negative 2 is positive 2 added to 0. So that'll be 2 and 0 is 2. So I get a quadratic equation. Okay, so I try to set this up so I can solve it by factoring. Okay, add a negative 2 to both sides because I want one side to be 0 in order for the factoring technique to work. So I get this equation. Okay, then I factor this. Okay, factors of 2x squared are going to be 2x and x, or x into x. Factors of 2 are 1 and 2, or 2 and 1. And because the last term, or the third term is negative, I have to have opposite signs here. So I have to have a plus and a minus, or a minus and a plus. So I have to set this up so that when I multiply it, I get this middle term of negative 3x. So the best way to do that is put a minus 2 here and a plus 1 here. And then check this out. X times 2x is 2x squared. Minus 2 times 1 is minus 2. And then 1 times x is x. Minus 2 times 2x is minus 4x. Add those together, we get negative 3x. So I get the factoring. Okay, set each factor equal to 0. And it should be clear to you that from the first factor, then x could be negative 1/2. And from the second factor, x could be 2. Okay, so this basically tells me that the graphs intersect at points where x is negative 1/2 and x is equal to 2. So to solve the system, which is what we're doing when we're actually finding the points of intersection of the two graphs, and that's basically solving the system. That's giving me the ordered pairs that lie on both graphs. So all I have to do then is find the y that goes with this x of negative 1/2, find the y that goes with this x equal to 2. So I would go back to these two equations here, either one. I'm going to take the first equation and solve it for y. Okay, so bring the 2 over. This will give me a plus 2 here. And take the y over. So I get y is equal to 3x plus 2. Okay, so now if x is equal to negative 1/2, now I want the y that goes with that. So if x is equal to negative 1/2, what is the corresponding y? So put a negative 1/2 right here where the x is rather, and this comes out to a negative 3/2 plus 2, and then add these up. So common denominator is 2, so multiply here by 2 and by 2. So this will be 4 over 2. 4 over 2 minus 3/2 is 1/2. So when x is equal to negative 1/2, y is equal to 1/2. That's one of the points of intersection, so that's one solution. Now when x is equal to 2, put a 2 where the x is over here. 2 times 3 is 6, and 2 is 8. So when x is equal to 2, y equals to 8. So the two graphs intersect at the point negative 1/2 and 1/2 and 2 and 8. That's your solution. Clear this. And then you can write this as a solution pair like this, okay? Depending how your instructor wants it. So negative 1/2 and 1/2 is one solution, and 2 and 8 is the other one. And of course, you can always go back and check the equations by plugging in the values that you got in for x and for y, and it should give you the numbers on the right side. That's one way to check it. Okay. Now the next one, a little bit more complicated. Look at the first equation. The second one has an x over here in the bottom, this term right here, so always clear it of fractions. So I'm going to multiply the second equation here by x. Okay, so this would give me x squared. X times x is x squared. X times 1 is x. Plus, and then multiplying the second term by x, the x's cancel, and that leaves me with y squared minus y. Equal to 0. Okay, so remember, my object is always to try to simplify the two equations by adding the two equations, or multiplying one of the equations by something, or both equations by something, in order to cancel one or more variables when I add them. Okay, so now I'm dealing with the second equation, then becomes x squared plus x plus y squared minus y equal to 0. Okay, so you can see that the first one has an x squared and a y squared. So let's do this. Let's multiply the first equation by negative 1. Or I could multiply the second, okay? Doesn't really matter. You can come up with the same thing. So notice minus 1 times x squared is minus x squared. Now we're going to add them. Properties of equality is what we're using here. So the x squareds are going to cancel. Okay? And then notice minus 1 times x is minus x. Added to the x. That's going to cancel. Okay? and then minus y, minus 1 times a negative 3y is a plus 3y. Okay, added to a minus y is 2y. Okay, and then minus 1 times 2 is minus 2. Added to the second equation is just minus 2. Minus 1 times 0 is 0. Added to 0 is 0, so I get this. Okay, so just by multiplying the first equation by negative 1 and then adding the corresponding terms to the transformed equation that I got here after I multiply 2 by x, I get 2y minus 2 is equal to 0. Okay, so then solve this for y. See, one equation with one variable. So I get 2y, add 2 to both sides, so I get a 2 here. Divide by 2, get y is equal to 1. Okay, so now when y is equal to 1, I want to know what the x is. So go back to either equation, either this transformed or the first one. I'm going to go to the first one and just replace the x, or the y rather, by 1. Okay, so go over here, x squared plus x and then put a 1 where the y is. So this will be y squared, so it'll be 1 squared, that'll be 1. And then here, minus 3y, but y is 1, so that's minus 3. And then plus 2. Equal to 0. Okay, so this is then x squared plus x. And then just simplify this. 1 minus 3 is negative 2. Added to 2 is 0. Okay, so that cancels out. And I get x squared plus x is equal to 0. It's a quadratic. So I solve this by factoring. Take out an x. So I get x times x plus 1 is equal to 0. Okay, so the right side is 0, so because I have it factored out, then I set these two factors equal to 0, so I get one answer to be, that could be x equal to 0. And if I set x plus 1 equal to 0, I get x is equal to negative 1. Okay. So this tells me that when y is equal to 1, I could have two possible answers for x. X could be 0 or x could be negative 1. Okay, so remember, you always have to go back and check your answers. The x equals 0 is not going to work, because keep in mind that whenever you're checking, you have to check the original equation. So go back to the first two equations. Notice here in the second equation, I have y squared minus y over x. If I let x be 0, I'm dividing by 0. So remember, division by 0 is not defined. So the x equals 0, I got to throw that one away, reject it. That's out. X equal to negative 1 will work. Okay, so these two graphs then would intersect at x equal negative 1 and y is equal to 1. So that's your solution. You could go back and check it. Check the first one, plug in negative 1 where the x is, plug y equal plug in 1 where the y is, and you're going to get the 0 on the right side, and the same thing for the second equation. Always check the original equation. So that's your solution. So again, it's in a solution pair. We could write it this way in braces, and the order pair would be negative 1 and 1. Let's go to the next one. 2x squared minus xy plus y squared is equal to 8. The first equation is second degree. In this case, the second equation is also second degree because it's x times y. So that term has a degree of 2 then. So a couple of ways that I could work this. I could solve the equation, the second equation for y or for x, it doesn't matter, but I say I solve it for y, then I would have y is equal to 4 over x. And then I would make that substitution into the first equation. Where the y is, I would put 4 over x, and then I would have an equation with just one variable. Okay, that's one way I could do it. Or I could just say, okay, I have a 2x squared here minus xy plus y squared. So if I add the two equations, then I would get 2x squared and the minus xy and the xy would cancel, plus y squared is equal to 12. Okay, so again, just adding them, I get 2x squared minus xy and xy cancel, I get y squared, and then 8 and 4 is 12. Okay. I still have two variables though, but then I could say, okay, let's have 2x squared plus, and then y squared, and let's replace the y here by 4 over x. This is quantity squared, equal to 12. Okay, so then this becomes 2x squared plus 4 over x squared. It will be 16 over x squared equal to 12. Okay, now I have an equation with one variable, and it's got a denominator of x squared, so just to make it simpler, I multiply through by x squared, get rid of the fraction. Okay, so I'll come back up here, then multiplying every term of both sides of the equation by x squared, I get 2x to the 4th plus, and then the second term here on the left side, the x squareds cancel, so this just gives me 16. And then x squared times 12 is 12x squared. So this becomes then 2x to the 4th minus 12x squared. So I'm adding a negative 12x squared to both sides to make one side 0. Plus 16 is equal to 0. And then just to make it simpler, since I can see that every term is divisible by 2, I divide through by 2. So this will be then x to the 4th, dividing that first term by 2. Second term by 2 is negative 6x to the 2nd. And 16 divided by 2 is 8, equal to 0. Okay, so then this factors into x squared minus 4 and x squared minus 2 equal to 0. Okay. So x squared minus 4 can be 0, or x squared minus 2 can be 0. So if I set those equal to 0, then the first equation would give me x squared equal to 4 if I solve for the x squared, and the second equation would give me x squared equal to 2. Okay, x squared minus 4 can be 0, so that means x squared could be 4. X squared minus 2 could be 0, which means x squared could equal to 2. And then I just solve this, take the square root, positive and the negative. Okay, otherwise you're going to omit a solution. So this tells me that x could be plus or minus 2. Over here, taking the positive negative square root, x could be plus or minus square root of 2. Okay. And then I go back and substitute into one of the equations. And you always, when you go back and substitute, always take the simpler equation. Notice I could plug in a 2 over here into the first equation, but xy is equal to 4. I have it set here for y, so it's easy to substitute in this equation here. So I'll say then if x is equal to 2, put a 2 where the x is here, y equal 4 over x, then y could be 2. Okay? If x is equal to negative 2, put a negative 2 here, so 4 divided by negative 2 is negative 2, then y could be negative 2. Y can be negative 2. Okay, so one solution would be the point 2, 2. Another solution would be the point negative 2 and negative 2. Okay. Now, on this one, on the second one, x can also be a positive radical 2. So if x is equal to the square root of 2, okay, so we'll plug it in then where the x is over here. Then let me do it up here. Y is equal to 4 over, and then the square root of 2. Okay, and generally we simplify this. So I'd multiply this by the square root of 2 and the square root of 2. So this would give me 4 radical 2. And radical 2 times radical 2 is radical 4. The square root of 4 is 2. Okay, so I get 2. 2 into the 4 is 2, so I get 2 radical 2. So if x is equal to radical 2, or the square root of 2, then y can be 2 times the square root of 2. And then in the second case scenario, if x is equal to negative the square root of 2, notice it's going to be the same. It's going to be the same setup, except you're going to have a negative here all the way through. So this will come out to y is equal to negative 2 square root of 2. So one solution is x equal 2, y equal 2. Another solution is x equal negative 2, y equal negative 2. Okay, another solution is x equal radical 2, y equal 2 radical 2, x equal negative radical 2, and y equal negative 2 radical 2. Okay, and if you write those in terms of ordered pairs, then it would look like this. So you have 4 solution pairs. So the graphs intersect. The graphs intersect at 4 points: 2 and 2, negative 2 and negative 2, minus radical 2, minus 2 radical 2, radical 2, and positive 2 radical 2. Okay. So in solving these, you're using elimination, using a little bit of substitution. For example, in the first equation that I did, I could have just solved the second equation for y and said this is 2x squared equal to y. Oops. Y is equal to 2x squared. Okay, so I could take that second equation, solve it for y, and then made a substitution into the first one. So where I have the y right here, I would have replaced it by negative 2x squared. I would have gotten the same equation as I got by elimination and gotten the same solution. Okay, so there's various ways to do this. Okay, so like I said, this will be the final video in this particular series. I hope that these have been helpful to you. I will continue with other videos. If you have any suggestions, please post them. Let me know what type of videos you want to see. I do have another channel, as I mentioned before, Dr. T. Math and More. I'll be posting some stuff on that channel dealing with set operations and applications coming in the next few days. So again, I'll leave a link to that if you're interested. So I hope these again have been helpful, and we'll see you in the next video.